We have this very interesting coordinate geometry problem. So what it says that the shortest distance from the point x0 y0 to the line ax plus by plus c equals 0 is the absolute value of ax0 plus by0 plus c divided by a squared plus b squared. So it's like a really interesting problem. And what happened here is, you can see we simply substitute the coordinate x0 y0 to the equation. That's what the numerator is, and take the absolute value because it should be a positive value, and then divided by the a squared plus b squared square root. That's like you square the coefficients and then add them and take the square root. This is like a very interesting problem. So you can find this problem in coordinate geometry. And yeah, so now let's try to see like how you can prove this result using calculus. You can see this is an interesting optimization problem. So what you try to do, you try to minimize the distance between the point and the line. So we have a line, so we can try to minimize this distance d. That's the whole point here. So that's why this is like an optimization problem. So let's try to see how we can approach this problem using calculus. So we have the point and the line. So first thing that we are gonna do is, so you can see that you also know that when you have a linear equation like ax plus by plus c equals 0, that actually represents a line. So you know that. So because you solve this one for y, once you solve this one for y, you can see that this is going to be y equal mx plus b form. So that's a line. So, but to use in calculus here, what we're gonna do, we're gonna do something interesting. We're gonna do what we're gonna parameterize this line. What is parameterized means, you're gonna use the parameter to represent any point on the line. So that's the first step, parameterize the point on the line. To do that, what we can do, we're gonna say x equal t. So t is the parameter. So x equal t. If x equal t, we're gonna solve for what is y equal. So we're gonna solve for y. So that's using the parameter. And then you're gonna also say that this parameter t is any real number, and what will happen when t moves is going to give you all the points on the line. Actually, you can just use x for that, but just try to show you like a different approach, like how to do a problem like that. So now what we can do, we're going to solve for y. So let's do that. So we know that a x become t plus by plus c equals 0. So what you're going to do is you're going to solve for we're going to solve for y. So we're going to leave by on this side and move all the other terms to the other side. So it's a negative at, negative c, and then divide by b. So once you divide by b, you're going to see negative. You can pull that out actually. So it's at plus c divided by b. So that is the parametric version of the y coordinate. So that means any point can be given by, so any point on the line is given by, so the x coordinate is t, the y coordinate is negative, you can see at plus c divided by b. So that is the y coordinate. So that means this can represent all the points on the line. Now what we're going to do, we're going to find the distance to this point and the given point. So that means this is the point for any t. So what we're going to do, we're going to find this distance between the given point and this special point. So you can see this point is P. And then what we're going to do, we're going to see for what t value you get the minimum for this distance. And then that particular t value, we can call that t naught, is the value we are looking for. For what t value you get the minimum. So that means you can see, now we're going to use the distance formula. And once we get the distance formula, we're going to minimize the distance. So it's a calculus problem now. So let's do that part now. So by the distance formula, we can say the distance squared. We can add the distance squared. So is simply x naught minus this value. This point has a t, so it's squared, plus, and the other one is y naught minus the other one. So, and you can see the other one has a negative sign, so it becomes positive c plus at divided by b. and you can see, so this is very clear, square. So that is this simply coming from the distance formula, because you know the distance formula. Distance formula is d squared x minus x naught squared plus y minus y naught squared square. So that's the distance squared. So what we write here is, and you can see, so these are the varies, the changing values. So in this case, those are the x and y values. X naught and y naught we know. So we can plug in here. Now what we can do, we can, you can see this is a function of t now. So you can say this function, let's call it LT. So that's the function LT. So that's the same one. So we can call it like that just to make things easy. So we just rename, and we didn't do anything else, just rename. Now what we do, we know the calculus part. So what we do, find the critical point, right? So that means, so find the critical point. For that, what we do, take the derivative. So it is dl over dt, dl over dt. So let's take the derivative. So this is very easy. Use the chain rule. So it is 2 x naught minus t times, take the derivative of the inside function, which is inside function negative t. So that means you get a negative 1 plus the same thing on the other side. So 2, you get y naught plus c plus at over b times. Now you can see this is the inside function here. So when you take the derivative, you're going to get the a over b term. So you get a over b. And then what we can do for critical points, we can set this one equal to 0. So that's like a normal idea here. Okay, so we set this in, and then we can solve for this special t value. So this can see 2 get cancelled out. So let's solve for t. So what I normally do is, like, let's distribute this one. So if you distribute, you're gonna see that you're gonna get negative x naught and then positive t, and then for the other terms you can see that you're gonna get a over b y naught. That's for the first term. You're going to multiply with this, and then you also multiply the other terms. So you can see that you're going to get ca plus a squared t divided by b squared, which is equal to 0. That's what you get. And then so let's just keep going until you find the t value. So you can see, so you can call this special t value is t naught. So if I say t naught, that's a special value, that's a critical point. You can see this is simply going to be x naught b squared minus ab y naught minus ca divided by a squared plus b squared. See whether you're gonna get that. So this is like just a little bit of algebra here. So you should get this one. So that's the critical point now. So you get this critical point. So take your time, get a paper, and write it down and see whether you can get this this term as the critical point. Now you can actually show that that's a critical point. If you look at the second derivative, so let's look at the second derivative. So you will see that the second derivative is, which is d squared L over dt squared, which is 1 plus, you can see that you're going to get a squared over b squared. And you can see, we know that these are all positive, so that means this should be greater than 0 by the second derivative test. By the second derivative test, and you will see that there is has a minimum. So has a minimum. So that means this problem is automatically a minimum problem. So now what we're going to do to find the minimum, so we'll see, you can see that the d squared, the minimum value is when you plug in t naught. So that means it's going to be x naught minus t naught value squared plus y naught minus the other value from the parameter. So you can see that it is going to be c over b plus a over b t naught. So that's the 1 and square. So so what we need to do is, now we need to plug into t naught that we already know. Just plug in and simplify. So it's just the algebra part now. We just need to plug in and simplify because we already know the t naught value. So let's do that. So it's going to be, So this is going to be the first term. So I just substitute there and take the common denominator also. That's the reason why you have a squared plus b squared. Take the common denominator. So that is the first term. So let's try the second term as well. So to take a paper and write it down and simplify this one. So then you can see whether you get the same answer. And then let's do the other one. So the second term going to be, so you get this one as a second term. So here this is the t naught term. So it's substitute for t naught. Now what we need to do is simplify this one. Just take the common denominator and simplify. And you will see that a lot of terms get cancelled. It's really neat. You will see a lot of terms get cancelled. For example, you can see that so we have x naught b naught. So you can see this term get cancels with this term, this product. So I mean you can cancel that term, so it's going to cancel the whole product. So that term is gone. And then you can see that's the only thing left here. And then from the rest of the terms, actually you can see a is common. And then because of the square, you can see a squared is common. So you can pull out the a squared term. That's what we do the first one. Second one also, take the common denominator as b. So for the second term, the common denominator going to be b times a squared plus b squared. That's the common denominator. And see whether you get the common denominator and see what is going to simplify. And you can see there are a lot of terms get cancelled again. So we can write this term next. So we have this one. So you can see the a squared is common now because you get a is common, but because of the square, so a squared is common. So let's try to get the second term. So for the other term, you get this one. So it is b times a squared plus b squared y naught plus c times a squared plus b squared, and then a times a x naught b minus ab y naught minus c a. So now you can see there are a lot of terms get cancelled out. For example, we have a negative a squared b y naught. So that term get cancelled out with this product because the b a squared y naught cancel out. And also you can see that the last term, so a squared minus c, this term get cancelled out with this one. So after you remove all those terms, all the cancel all the terms, you can see you can write the final product like this. So you're gonna get that. So this is the first term, and the second term you can see you have a b squared as a common factor, and everything else is the same. So x naught a plus y naught b plus c squared over a squared plus b squared. Now what we do, we can take the common denominator again, they are the same. So once you take the common denominator, you can see that you're going to create a factor a squared plus b squared. That means one of the factors get cancelled out, so you finally get this one. And so this is what you get. Now you can see this is the d squared, so that means the minimum d is the square root. But once you take the square root and you know this result, when you square and take the square root, it is actually equal to the absolute value of x. So that's where the absolute value coming. That's from the numerator. And then so you're gonna write this one as the final answer after you take the square root. So the d minimum is the absolute value of, you can say a x naught plus b y naught plus c divided by a squared plus b squared. So this is how you use this nice coordinate geometry problem using calculus. So now take a paper and try to do all of those math again, because you see that there are a lot of algebra. The calculus part is really easy. It just really just the algebra part. So see whether you can do the same thing. So let's do the next one.